I'm Hanamantray Baluragi, Director for Directorate of Human Space Program at ISRO headquarters. I'll be talking about India's human space program, and mainly focusing on the activities involved in ongoing Gaganyaan program, and also covering on the activities and developments and missions that are involved in Gaganyaan program missions that were recently approved by Government of India. So over the years, ISRO has developed various launch vehicles and spacecrafts catering to remote sensing, communication, and space science applications. As on today, ISRO has accomplished 97 launch vehicle missions and 125 spacecraft missions, and it also includes 5 re-entry missions consisting of 3 RLV landing experiments and 1 each of space recovery experiment and care experiment. The whole idea of pursuing human spaceflight mission by India was based on confidence gained from some of the previous technology demonstration missions like space recovery experiment, care experiments, and pad abort tests. Journey towards human space program started with the successful completion of space recovery experiment in year 2007, wherein safe return of spacecraft to Earth was demonstrated involving performance validation of lightweight thermal protection material against the high re-entry heat, further navigation guidance and control for re-entry body, deceleration systems and recovery operations were validated in space recovery experiment. And also few microgravity experiments in space were also conducted. In 2014, crew module atmospheric re-entry experiment was conducted successfully and tested re-entry technologies that were envisaged for crew module and validating performance of parachute-based deceleration system. This mission provided enhanced understanding of blunt body re-entry, aerothermodynamics, and parachute deployment in cluster configuration. Further, in 2018, ISRO conducted successfully crew escape system simulating a pad abort scenario of a launch vehicle. This test demonstrated the safe recovery of crew module in the event of any exigency at launch pad. These missions provided required confidence to undertake human space missions. So coming to Gaganyaan configuration, Gaganyaan program was formally initiated with the announcement by Honorable Prime Minister on the eve of 72nd Indian Independence Day. The main aim of Gaganyaan program is to demonstrate end-to-end technology for indigenous human spaceflight capability. So LU-3 vehicle with its payload capability and its simple, robust architecture was the natural choice for human space program. And to achieve required reliability factor for human rating standards, various systems have been upgraded with necessary features. The other two important elements in Gaganyaan configuration includes crew escape system and orbital module. So crew escape system is basically a fast-acting solid propulsion-based system assembled over the orbital module that ensures safety of the crew in the case of any malfunctioning of launch vehicle. Orbital module consisting of two elements, which one is crew module and another one is service module. Crew module provides like Earth-like atmosphere and protects the crew members from the harsh space environment during launch re-entry of the mission. It primarily comprises of a pressurized structure, critical environment control and life support system, thermal protection systems for re-entry heat protection, propulsion system, and associated avionics elements. Whereas the service module primarily provides necessary storage for consumables such as oxygen, provides power for onboard operations, as well as it houses propulsion system which is used for executing various orbital maneuvers. The Gaganyaan module or orbital module is configured for catering to crew up to 3 members, and it can have a mission duration up to 3 days, and it will be put in by human-rated launch vehicle in 400-kilometer orbit, and recovery of this orbit module takes place in Arabian Sea or Bay of Bengal. Coming to just to compare what are the difference between the operational launch vehicle and spacecraft missions and Gaganyaan missions. When it comes to Gaganyaan missions, where crew is involved, we refer it as a human-rated space systems. When it comes to involvement of crew, we have to accommodate the needs of the crew, which we refer it as a anthropometry and ergonomics. And we also need to ensure fundamental human physiological needs that have to be satisfied in the design of the systems or in the development of the systems, which is referred as human factors and life supports. And we need to make use of human capabilities as an integral element of design and operation of the vehicle, which is, we refer it as a crew intervention. So effectively utilize their capabilities to accomplish the mission objectives and protect the crew members during phases of mission, which we refer it as a crew performance. All these put together is referred as a concept of human rating. So basically, human rating helps us to improve the reliability of launch vehicles for human use and increasing safety through addition of escape or abort system. So Gaganyaan is a human-centered mission. It incorporates human needs and performance in design of various engineering systems, and which is new area for ISRO. Generally, ISRO spacecraft missions are tailored towards maximizing payload launch to orbit, whereas Gaganyaan is tailored towards ensuring crew safety. So this requires additional rigor in system design and adherence to human rating certification standards and guidelines. On the right side, you can observe the basic difference between the operational LVM3 vehicle and human-rated LVM3 vehicle. If you look at the design philosophy, the operational vehicle is maximized for deploying the payload, whereas HRLV or human-rated LVM3 is modified to catering to the crew safety at any instant. And it comes to improving the margins or design margins, the factor of safety that has been employed for a regular operational vehicle is around 1.25 for structures and 2 for gas bottles, whereas for human rated vehicle it is 1.4 and 2. And operational vehicle is dual redundant, whereas for human rated it is quadruple redundant. So this improves the reliability of the vehicle. And fault detection is ensured through in HRLB integrated vehicle health management. So various systems are monitored regularly. All sensor data has been assimilated, and decisions are made based upon the data or models. So then the contingency plan, what is additional in human-rated launch vehicle is fast-acting solid motor-based crew escape systems. These are the major difference between the Gaganyaan missions and the operational missions. So this necessitates so development of various new technologies, extensive validation of these technologies on the ground before we undertake the missions. Coming to various new technologies and the complexities involved, if you look at the engineering systems, so there are 3 parts here. Human-rated launch vehicle is 1, and the orbital module is next, and the end-to-end mission is the 3rd one. And the other aspect is human-centric system. So new elements in launch vehicle include human rating of all propulsion systems, enhancing design margins, crew escape system for crew safety in the event of failure of launch vehicle, quadruple avionics for enhancing reliability, and integrated health management for fault detection and safety actions. Some of the new technologies for orbital module includes green propulsion for ensuring safety of the crew, thermal protection system that can withstand high heat during re-entry into Earth's atmosphere, human factor engineering, and space-grade parachutes. Gaganyaan crew operations are being planned by ISRO. Expertise and assets from national agencies will be pooled. The human rating of launch vehicle is being carried out by improving the structural margins, incorporating redundancies in the avionics systems to achieve desired fault tolerance capability. Coming to human-centric system, there are so many systems that are being developed for catering to the human requirement, which consist of life support system that ensures the 1 bar pressure in the crew module, that also ensures the required concentration of oxygen. Then flight suit in the event of depressurization of crew module in the event of it. So that is also being developed and implemented for this. The other systems like in-flight nutrition and health are essential. So then further requirements like medical and survival kits have to be made available in the crew module. The astronauts for Gaganyaan mission were selected from a pool of qualified test pilots from Indian Air Force. Post-selection, the 4 Gaganyatris have completed their generic spaceflight training in Gagarin Cosmonaut Training Center, Russia. Subsequently, the Gaganyatris have completed 2 out of 3 semesters of their Gaganyaan mission-specific training in India. Currently, Gaganyatris are going through Gaganyaan-specific training. Gaganayatri training covers various theoretical subjects, in-depth familiarization with various Gaganyaan orbital module systems, survival training for various off-nominal scenarios, activities at launchpad as well as flight procedures on Gaganyaan training simulators. The Gaganyaan athletes have been familiar with microgravity for short duration through parabolic flights. Other human-centric systems that I mentioned earlier includes basically life support systems and various other systems. Coming to various missions that have been planned under ongoing Gaganyaan mission includes, there are 4 test vehicle missions in order to simulate in-flight abort conditions. It means that during ascent phase of launch vehicle, there are possibility of failure of the vehicle. In any case, in any failure situation, the integrated health management system of vehicle provides a command to the crew escape system, and that crew escape system safely takes the crew module away from the vehicle, and safely further safe operations are executed and landed in ocean. And to cater to simulate or validate crew escape system in all these scenarios, 4 test vehicle missions will be conducted, of which 1 has been successfully completed last year, October 2023. There is a deceleration system that has to function while crew module coming back to Earth, and this system has to be rigorously tested and verified, validated in the flight, undertaking mission simulation flights that we refer to the integrated airdrop test, basically qualifies deceleration system. So large number of tests are planned under this. And the main missions include 4 missions. 1 will be uncrewed. The first mission is uncrewed, that we refer to as G1, which will be utilizing unpressurized crew module. Basically, this mission is targeted as an early flight to test and validate new technologies that are being developed for Gaganyaan program. And it also helps us to execute end-to-end mission sequence. It involving crew escape system separation, then recovery procedures, and network coverage at various locations throughout the mission. And it also helps us to execute or validate entire recovery operations of crew module from the ocean. Subsequent to this, we are planning two uncrewed missions, and both missions are identical with crewed missions, and this is the requirement of human rating certification. And in the 2 uncrewed missions, G2 and G3, we will be demonstrating and performing validating various systems, and we will be testing humanoid and anthropometric dummies and simulating various conditions for crew and validating various systems. And repeat uncrewed missions is essential to meet certification requirements, and we'll be conducting some of microgravity experiments. And after this successful completion of 2 uncrewed missions, we'll be undertaking one crewed missions, and in which human space mission operations protocols will be validated and tested, and the validation of crew rehabilitation procedures, and crewing loop demonstration of free launch infrastructure. Subsequent to Gaganyaan program, these 4 missions, Government of India has already laid out a vision for Indian human space exploration program. The goal is to fully achieve the capability of long duration human spaceflight missions through an operational Bharatiya Antariksh station by 2035 and achieve Indian landing on moon by 2040. Sustained human presence in space through the Gaganyaan program will also boost national microgravity research ecosystems and give impetus to the overall national space economy. The focus of ongoing Gaganyaan program is to achieve indigenous basic capabilities for transportation of crew to low Earth orbit and bringing back safely to Earth. After achieving basic capabilities, the next logical step is for crew habitation for medium and long duration missions through establishment of space station capabilities that we refer it as a Bharatiya Antariksh station or shortly BAS. Towards achieving indigenous capabilities for long duration human space missions, ISRO has finalized Bharatiya Antariksh station and it is expected to be operational by 2035. Under phase 2, essential technologies for BAS will be developed and validated through 4 precursor missions. Recently, Government of India has approved the development of base module of BAS and 4 precursor missions to validate additional technologies for long duration human space missions. Based on the experiences and technologies developed under the ongoing Gaganyaan program and for the BAS, which will enable ISRO to define the space systems for mission to Indian landing on moon. This is targeted by 2040. If we look at it, the various technologies that are being developed under ongoing Gaganyaan missions and the incremental technologies that are essential for Bharatiya Antariksh station, these are essential for establishing sustained presence in space that requires a demonstration of enabling technologies such as large space habitats, life support system for long duration missions, autonomous or crewing life rendezvous and docking, micrometeoroid and orbital debris protection, robotic manipulators, onboard scientific research equipment, maintenance tasks, logistics resupply missions, as well as crewed mission support operations for extended duration. So Gaganyaan follow-on missions, including the launch of BAS-1, BAS-01 module will be tailored towards achieving these development activities. Rendezvous and docking is a crucial technology element for BAS. It consists of both soft capture and hard capture systems, including docking control system. The soft capture provides the first level of attachment where attenuation and alignment between the 2 vehicles following initial impact, whereas the hard capture system performs the final structural meeting between the 2 vehicles and establishing a connection capable of withstanding internal pressure combined with loads from planned mated operations to the 2 spacecrafts. So MMOD impacts pose severe threat to human spaceflight missions. The conjunction from catalog debris is prevented through collision avoidance maneuvers, whereas the risk from the non-catalog debris, that is basically the dimensions less than 10 centimeter, is reduced through implementation of passive seals, for which we are developing MMOD. Large robotic arms manufacturers will be developed and deployed in BAS for activities such as assembly operations, spacecraft berthing operations, assisting astronaut during EVA activities, external payload operations. Scientific experiment is basically a unified system that provides all requirements for scientific experiments under microgravity on board BAS. This rack interfaces with experiment and provides 2-way interface for power, fluid, and data. Space habitats involve a complex and tightly coupled combination of hardware, software, and humans to meet challenging space environments that poses many risks, as I mentioned earlier. Designing of space habitat will be based on human factors that becomes essential for long duration mission, It has to accommodate mission-specific tasks and what all need to satisfy basic human needs of eating, sleeping, exercising, and personal hygiene. So technologies that are under development for Gaganyaan and technologies planned for BAS together will enable ISRO for operationalization of BAS and subsequent crewed missions involving long durations. So I have summarized here all the technologies of that are required for incremental technologies that are required for BAS that will be developed and validated in 4 precursor missions for BAS. So which consisting of one crewed mission and 1 space docking mission and development and launch of BAS base module and docking of orbital module to BAS first module. I'll come in detail on each of these mission. So in the H2 mission, that is, this will be the second crewed mission. As I mentioned, under ongoing Gaganyaan program, there will be first crewed mission, and this will be the second crewed mission. And basically, this is to demonstrate a multi-crew mission for maximum duration and performance validation and operation protocols of environment control and life source systems, personal hygiene and waste management system, human psychological effects and mitigation strategies, and microgravity experiment protocol procedures. And this will also demonstrate one of the important technology that is essential for the Bharatiya Antariksh station, that is human-in-loop orbit maneuvers and associated avionics systems for future docking missions to BAS. And it will, by the time we are expecting to develop internal vehicular activities spacesuit indigenously. Right now we are sourced from a foreign country, and the development or demonstration of operational 5-way suit also is expected in this mission. And this mission will be for maximum crew and maximum duration and catering to all these mission objectives. Coming to mission, space docking mission, this is another important technology I mentioned, docking, rendover docking system development and induction of that system for Bharatiya Antariksh station. And this mission is uncrewed mission. So basically to demonstrate interoperability of Gaganyaan module or orbital module with the space station of other nations. So this mission demonstrates autonomous rendover and docking, will enable gaining experience in mission management aspects through international collaboration, demonstrate indigenous viewport, and reusability of structure and avionics system. Considering the complex nature of docking technology, we are proposing to source this docking technology through international collaboration, and also we are initiating indigenous development of a docking system referred as a Bharatiya docking system for future BAS configurations. Indigenous viewport assembly would also be integrated into this module, and crew suite automation system will also be upgraded, and these technologies will be demonstrated in this space docking mission, which is uncrewed, and this is expected to be launched on board operational LVM-3 launch vehicle. So coming to Bharatiya Antariksh station, so before going to BAS-1 mission, I'm going to just give a brief idea about overall configuration. Bharatiya Antariksh station is a 5-module configuration, and which is basically finalized based upon the various constraints and trade-offs with respect to launch vehicle capacity, payload, and types of orbit, technological complexities. So ISRO has finalized the 5-module configuration of BAS. So these 5 modules are referred as a base module, core module, science module, lab module, and common berthing module. These all put together weigh around 50 tons. So 3 modules will be arranged in linear orientation, and 2 will be orthogonal to the main axis. All modules of BAS will have independent solar panels except for 5th module of BAS. The deployment and launch of first BAS module is planned by 2028, and this will be followed up with addition of further modules, and the station is envisaged to be fully operational by 2035. When it comes to details of base module, BAS1 module, so configuration is like this. BAS01 is the first module of BAS, also known as a base module. This module will serve as a test bed for validation of several new technologies such as rendezvous docking, orbit maintenance, orbit boosting, cabin integrity, effectiveness of radiation and MMOD shielding, and communication systems. The base module will have a non-regenerative environment control and life support system with nitrogen and oxygen gas for leak compensation and airlock operations, and thermal and humidity control systems and other ECLS interfaces for future expansions will be provided in BAS1 module. And the module will have microrotary experiment tracks, crew quarters, and one personal hygiene system. And viewports will be provided to ensure safe docking of crew or cargo module that is coming to dock with BAS, and also it will also ensure psychological well-being of the astronauts. So measurement of radiation and thermal environment is also one of the primary objective of base module, and to understand the environment for safety of the future crewed missions. So orbit rising and control operations are also planned using full-fledged propulsion system in BAS1. So coming to the mission, so base module is planned to be developed and launched on board LVM3 vehicle by 2028, and basically to demonstrate new technologies. That's what I mentioned earlier. And post-launch, BAS1 will be initially operated in uncrewed mode for obtaining flight data for performance validation of various onboard systems. So basically, we'll be using BAS1 as a test bed for demonstrating various technologies. Further, when second module, third module is get attached to the BAS1 by docking system, which will be further used for crewed missions for short duration. And when it's fully operational with all 5 modules, and at that point of time, our crew can stay for longer durations. Coming to the last mission, that is after a successful experience development of indigenous docking system, we'll be undertaking indigenous capability demonstration for autonomous rendezvous and docking, which will validate mission operations and protocol for robotic cargo transfer operations and demonstrate on-orbit refueling of BAS1 module. So this refueling is very essential for orbit or maintenance of BAS. So this uncrewed mission will be launched using LVM3 launch vehicle. So I have listed here mission objectives, various mission objectives, and with this mission, we'll be able to conclude development and validation and performance demonstration of various technologies that are essential for entire BAS, and this further studies on the BAS and generation of several engineering data for long duration that will enable for us to define the mission for crewed landing on moon. So coming to indigenous efforts, so many technologies or products that are being right now imported from other countries. So we have taken the action for indigenous development of some of these critical products. And basically the strategy what we applied right now is to, in order to reduce the risk of some of these important technology elements, we have gone for imported thing. And parallelly, we have initiated indigenous development of all of these systems, and some of these systems will be tested in precursor missions to BAS. So one important aspect of establishing any space station is to undertake microgravity-based research, and that provides a lot of opportunities for our academic and research organizations. And Human Space Program basically aims to provide opportunities for researchers to utilize the microgravity environment for scientific experiments. The experiments will cater to areas such as space biology, life sciences, advanced material development, healthcare and medical technologies, pharmaceutical development. These experiments will benefit further human space exploration activities, as well as to have multiple spin-off applications on Earth. These experiments have value creation opportunities in areas such as advanced metal synthesis, biomanufacturing, regenerative medicine, bioengineering space. There is also growing commercial interest. Gaganyaan mission will also inspire youth to take up careers in space-related activities. STEM education can also be promoted through demonstration in microgravity environment. So there is a wide spectrum of opportunities available, from being future Indian Gaganyatris to being a part of ISRO and industries in designing and realization of various human space systems. So the goal of Viksit Bharat will hinge on a transformative shift in the national research and development landscape. So research in human spaceflight missions is also a unique tool to educate and inspire next generation researchers. Talented youth can also take up research and technology development experiments that will be carried out in Gaganyaan missions, future Bharatiya Antariksh station, as well as joint international space missions. So I have mentioned here some of the important research platforms that are available right now, that is International Space Station, Taigong, and they have a dedicated space research facilities. 3,000 plus experiments have been conducted on ISS till now. And some of the major outcomes that have been described on the right side, involving like a cold plasma device development for healing wounds, and accelerated aging studies on osteoporosis treatment, and portable medical imaging devices, high quality optical fiber production. The major focus areas I mentioned earlier involves various areas where human-centric factors involving his health, physics, and long duration performance of various engineering systems and research on material development. So coming forward, some of the important missions that ISRO also is pursuing that are related to this long-term human space missions, which involve space docking experiment involving two systems, that is Chaser and Target. They will be launched on board PSLV in coming days shortly, and they will using these two satellites will be carrying out autonomous orbital rendezvous docking, and these two are built on Indian mini satellite bus, and so this has a direct application of docking systems that is being developed for Bharatiya Antariksh station. The another mission, important mission that has been recently approved by government, that is Chandrayaan-4 mission. It consists of 5 modules, like a descending module, ascending module, propulsion module, transfer module, and return module. So these 5 modules will be launched on board 2 launch vehicles, and this mission also carries out a lot of docking and unlocking operations in the space, autonomous operations. And this mission will have a lander landing on moon, collection of samples, few kilograms, and returning to Earth. So so entire mission operations, going to putting into Earth orbit, then traveling from Earth orbit to moon orbit, then landing on moon, taking off from moon to moon orbit, and coming back to Earth orbit and successfully landing. Entire end-to-end operations that is essential for Indian crewed mission to moon will be demonstrated in this mission. And of course, there are many subsequent follow-on Chandrayaan follow-on missions are also being planned, wherein high thrust propulsion systems and various technologies will be demonstrated and validated, and all technologies put together will enable us to define mission for crewed landing on moon by 2040. And coming to summarize, Indian space program is taking the next steps towards achieving indigenous capability for long duration human space missions, and 3 uncrewed missions prior to first crewed missions are planned under the ongoing Gaganyaan program. And India's space vision 2047 for human space program, which includes development and operationalization of Bharatiya Antariksh station by 2035 and crewed lunar landing to moon by 2040. So incremental technologies for BAS will be demonstrated and validated in 4 Precursor missions. So including these 4, and we have approval for total 8 missions under Gaganyaan program now. And the first module, base module of us is targeted by 2028. So with this, I conclude. Thank you very much.